Hey, welcome everybody. We are going to be reviewing some examples on the constant velocity. And we want to understand what physics is. We have to start here. So, physics. Yay, finally. We've done everything in order to do physics. Now we can do physics. So say that we have any object that would travel a distance of 10 meters. We can ask, what's their speed? They traveled 10 meters. What's their speed? Well, you might come up with an interesting question. In order to determine the speed, we kind of need to know the time that it took, right? So again, I'm letting you kind of make sense of these things. If it took 1 second, and the person traveled 10 meters, and it took them 1 second, then how can we express the speed? Maybe something like 10 meter per 1 second, right? That would be a good start. So 10 meter per 1 second. So 10 meter per 1 second sounds like a speed. It sure sounds like a speed to me. So 10 divided by 1 would be 10, and then meter per second kind of stays the same way. And if you look at this carefully, that is a speed. So this was a ratio, now this is a speed. Same things. But say instead maybe he took 2 seconds to do 10 meters. So the person would take 2 seconds to do 10 meters. So does it make sense now to say that his speed is 10 meters per 2 seconds? And if you divide the 10 by the 2, you'll get 5. And then the meter per second will stay the same. And that does make sense because we went from 10 meters per second when it took them 1 second to 5 meters per second when it took them 2 seconds. In other words, this first second they traveled the first 5, and the second they traveled the second 5 meters. And so we could recreate this situation by having someone walk at this speed. For the first second, they will travel 5 meters. And for the second, they will travel another 5 meters. Grand total of 2 seconds and 10 meters. We're back to this situation. But maybe it wasn't meters, maybe it was kilometers. Right? So what if they traveled 10 kilometers this time, and it took them 2 hours? So kind of the same situation, but kilometers and hours. So what happens to our speed? Well, let's take a look. 10 divided by 2 would be 5 again. But the units would be kilometer per hour. Kilometer divided by hours. So again, I'm not judging anything. I'm just writing what was. And I can recognize this. 5 kilometers per hour. That's a speed that we're kind of familiar with. That is not a fast speed if you're in a car. Kind of slow, right? Really, really slow. And if you think about it, if you go at this speed for 1 whole hour, you will still travel 5 kilometers. You're not going that slow. You're probably faster than a walker, and you're about the same speed as someone who's running, maybe jogging. So that's interesting. Wait a minute. What have we done? We've done something very special. We understand the relation between the meters and the seconds, and how the relation between the two gives us something that we humans know what to call. We call this the speed or the velocity. So basically, if the result of dividing those two things, let's write up here again. If this is the distance and this is the time, and by dividing them, I got what I call a velocity, then we can make this formula. Velocity would be the distance divided by the time. Not every time in mathematics can you put things that simple. But we have to start somewhere, and we're 13 years old, so let's start with that. It's a great start. I like it. By using this formula, if we put again the information, 10 meters, 2 seconds, we get 5 meters per second. Sorry about the limits. And 5 meters per second is a velocity. And it is the velocity in our situation. It's a rather simple situation where everything makes sense. There's nothing that does not make sense. Like 5 meters per second makes sense. It took them 2 seconds. They traveled 10 meters, right? So 10 meters at this speed takes me 2 seconds. It's really simple. And it works. Okay. So we're going to use this formula. How intriguing that from the real world data, right? 10 meters is a real thing. 2 seconds is a real thing if I count. So the velocity is definitely a real thing also. How interesting that we can take things, put them in the clouds with our formulas, come back with a real situation that applies in the real life. So we're going to take a look at those real situations. We're going to do 4 examples together, and hopefully that'll be enough. Sophie walks a distance of 300 meters. So in physics, there are ways to work. You always write your information first. 300 meters. D equals 300 meters. Now, don't think you're not doing anything. You're absolutely doing something when you're doing this. You're taking this 300 meter and you're assigning a letter to it. Why do we do that? Because we have formulas with letters in them. And so you're absolutely doing something here. Your brain associated these two things. You're actually doing more than that. But let's keep going and I'll show you. So that's really important. I'll leave that. What else do we take from our problem? It says in 60 seconds. What is that, 60 seconds? Which letter is that? That's the time, right? And then it says, what is Sophie's speed? So which letter is speed again? V. Why not S? Because V is for velocity. And velocity is the speed that you're going at. It's a little more than that, but we'll call this a constant velocity or a speed. And basically the paper says for this V letter, this is the question. What is the speed? So what is the V? So we'll put a question mark here. Now here's the second thing you've done by copying it here. Here's the second thing you've done. Notice how now we don't need to look at our paper anymore. We don't need to look back at it for anything. All we have to do is look back at on our paper, our personal paper. We have all the information that we need to do the math. So I don't have to look at this. I can actually remove it if I don't need it. And on this side, we write our problem. So one unknown, and we have all this. Which formula can we use, which is the only formula that we have? So V equals D over T. So we could use that formula to find our solution. We write the formula down, then we put things in there. Because it's such a nice formula, I'll keep going this way. 300 meter. Are you taking notes? You should be taking those notes for you. 300 meter divided by 60 seconds will give us what? So if we simplify 300 divided by 60, how many times 60 and 300? It's 5. You can also simplify the fraction, like divide by 10, divide by 10. So what's 30 divided by 6? 5. Right. 5 meter per second. So I just took the information. I didn't change anything. I just divided the thing and then I brought my units, meter, seconds. And we're done. It's well organized. We have the data, the formula, the work, the solution. That's 4 points. You get 4 points for this. 2. Mark left home at 4 p.m. and finds Paul sitting home at 5 p.m. Okay. If Mark's walking speed is 20 meters per second, what is the distance between Mark and Paul's house? Houses. Let me just save this. What do you mean? There's no save as? Oh, I'm gonna remove that intro stuff here. Oh, I didn't change the title. What's my title here? Constant velocity. These are exercises for constant velocity. Save. Holy, it's complicated. Make unwanted change. Don't show me again. Got it. It's auto-saving. Oh no. Oh no. Can I go back? Hold up. We're gonna fix this. Autosave is on. Okay. I'll just learn. Now we're gonna go back here because I want to save my French work. Made this up myself, so I'm gonna save it. Okay. Whoa, 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 whoa. All right. File, save as. Cool. FI physics. Place. Yes. Good. Close. Physics. All right. We're back. 2. Mark left home at 4. So big situation where Mark goes from this place to this place. It doesn't need to be straight. It could be like curved or from A to B. And you'll notice we'll call this one situation. So every time in physics where you work, it's from A to B. It's one situation. If I tell you a dog went to Mary's home and then back, and then it took him 3 more hours to come back or whatever, these are 2 situations. Going from one place to another is one situation. If you do some back and forth, that's multiple situations. Okay. So sometimes our formulas can incorporate them because it's actually one situation, but it's never one formula for 2 situations. That's never the case. So in this case, Marc is going from his home to Paul's home, and he's going from 4 p.m. to 5 p.m. So without telling you the time it took, you decided to tell us how much time it took. 1 hour. So T equals 1 hour. You may not notice, but in here, there's already like 2 points worth of thinking. You've figured out that which letter to use, which is T, and you've also figured out between 4 to 5 is 1 hour, which is your time that you're going to need. So nice work. What else do we get from the problem? So again, not trying to do the math, just trying to read first. This sentence is done. Marc's walking speed is 20 meters per second. Go here. And you write 20 meters per second. Which letter is that? T, D, V. Right? So V. Next question, or next part. What is the distance between Mark and Paul's houses? Distance is the question. Okay. So the first thing I want to do is going to be a bigger example because I want to show you where one would make a mistake. So let's take the formula. V equals D, sorry. It looks easy, okay? D over T. I'm going to show you what we normally do in 9th grade. Then I'm going to show you what we do in 10th grade. And we'll take tools from that to use in our grades. So now I'm going to make a mistake. So the first thing you could do is write here. So this is what we do in 9th grade. We keep the things we don't know as letters. There's a lot of things we do in 9th grade. It's normal and it's good. So all of this normal people do. D, T is 1 hour. So we're going to write 1. Now, I've made the mistake because D divided by 1 is D. And so is it good to say this? D is 20. We have a big problem with that. 20 what? Meters? Kilometers? It's irrelevant because it's wrong. And it doesn't really make sense. If he travels at 20 meters per second, and it took him 1 hour, how can the house be only 20 meters away from him? That doesn't work. Was it 20 kilometers? Well, if that was the case, it would take 1,000 seconds, and 1,000 seconds is not 1 hour. So it's not. That's why it's no good. So this is not going to work. It's a big X. We're going to take all this, move this to the side. The problem that we face is that the units here are not the same. Remember when you changed your units, how much is 1 hour in seconds, right? And minutes. So 1 hour, in order to be changed, in minutes. 1 hour is 60 minutes. And what did we do? We did time 60, right? 1 times 60 is 60. We did times 60 to get here. And how many seconds in a minute? 60. So times 60 again, you'll get 3,600 seconds. This number is the most important number, mostly for time and physics, because we often go from hours to seconds. So how do you get from 1 to 3,600? You do times 60, or times 3,600. So it's good to remember it by heart. So 1 hour is 3,600 seconds. And why does it care that we have seconds here and seconds there? Because they're the same, yes. And why do we care? Go back here. SI system. So the SI system says that your seconds is your time. Your lengths are in meters. So they're not in hours and kilometers, none of that. And why does it matter? Let's go down a little more. It matters. So these are the base units. What are those? If these are the base units, seconds, meter, kilogram, amps, Kelvin, what are these? So these are also units, like a Newton is a unit of force. A hertz is a unit of frequency. A joule is a unit of energy. And watts and coulombs and volts, you've heard those before. But inside those units are hidden base units right here. So a coulomb, for example, or a watt, for example, is a kilogram meter square per second 3. And you'll notice that it's meters and seconds. Meters and seconds. Meters and seconds. There's no hours and kilometers in any of that. Why? Because in order to get the right amount of newtons, we need to not make this mistake that we've made, because it did not give us the right amount with our units. So do you see? And we're going to do it now, but this time not with 1 hour, but with 3,600 seconds. And we're going to get a different answer, but an answer that works. So let's go. V equals D over T is the formula that we need to resolve this right here. We're going to put 20 here for the velocity. D stays the same. And T is, 3,600. All right. Now, I think we've also reorganized things last week. So what do we need to do here to reorganize this? So D is on top. That's good. But it's being divided by 3,600. We don't want that. So what's the opposite of dividing by 3,600? What's the opposite of dividing by 3,600 multiply by 3,600? So we're going to do that on both sides. I'm going to write 3,600. And I'm going to leave some space here for a good reason. Multiplied by 20 will be equal to D over 3,600 multiplied by 3,600. Okay, so up to now, everything's good. We can cross off those two, which was the goal, and we end up with this part. 3,600 times 20 equals D. The answer is 72,000 equals D. Nice. Now we need the units. So let's go take a look at what the units should be. First off, it's distance. So the unit should be in meters or kilometers or etc. We have taken the SI system, so we can expect to write meters. Because we've made sure when we took the data, we've made sure that it was SI, so our answer will be SI. But let's take a look at the formula itself. What would the formula tell us? So 3,600 what? 3,600 what? 3,600 seconds, right here. Right? You can write seconds here. And 20 what? Meter per second. So 20 meter divided by seconds. What happens to a second multiplied by a meter divided by a second? Right? So second times meter divided by seconds, or meter times seconds divided by seconds. The seconds cancel out, because a second divided by a second goes away. It goes back to this idea. Second over second is always 1. Like, it doesn't matter what it is. It cancels out. It is irrelevant. It is 1. It means nothing. So you end up with meters. See, the same meters. So we could have kept all of our units in there. It's just a lot more work. I don't think you need to do that. Start by making sure that this part is respecting of the SI system. If not respecting of the SI, at least that the question doesn't mind if you are in kilometer per hour or etc. Like the next question. So I want to do 2 more examples, and I want to grab a tool first and show you that also before and let you go. So a car travels a distance of 1 kilometer during a time of 1 hour. What's its speed? What is its speed? And we would like meters per second. If I didn't write meters per second, there is nothing wrong with keeping it in kilometer per hour. Like this. So say I didn't write, say I just wrote what's its speed. Well, you could have said this. 1 kilometer per 1 hour is equal to 1 kilometer per hour. And that would have been okay. Not only would it have been okay, it would have been great. 1 kilometer per hour. But we did write meter per second. So what do you want to do? So again, I suggest that we change these here, because there's nothing easier than doing it here. You're also saving time down the road. So 1 hour is how many seconds? 3,600 seconds. And 1 kilometer is how many meters? 1,000 meters. Now we're gonna rewrite this part. We're gonna say it was 1,000 meter divided by 3,600 seconds. The answer is, so you need a calculator. For some reason, I don't have a calculator, so I just Google it. I did it a minute ago. So 1,000 divided by 3,600, you get 0.27, 0. Or comma 278. You'll notice I have 3 digits. Oh, missing something. Missing the units. Meter per second. Right here. And that's our answer. And that's the end of the problem. Okay, so what do we do in 10th grade that is so different? We'll do it here. We'll come back here. So 10th grade, so in 10th grade, we're gonna let's go get some tools. Let's get tools. Let's get tools. We have practiced moving things around in the formulas. When we were faced with this, what did we do? We multiplied by the number on both sides, and it canceled out, right? We want to do that with the formulas. Am I going too fast right now? I'm sorry, I think I'm going a little too fast. Let's go get our tools from our last problem. A bicycle maintains a speed of 10 meters per second. V equals 10 meters per second for a distance of 1.5 kilometers. So again, I'm not changing it. I'm just taking it, putting it on my paper. How much time will the travel take? Time is the question. All right, so we got our good habits. We're developing good habits. Kilometer in meters would probably be preferential. We always look at the speed because we don't want to change the speed too much. We don't want to play with the speed if we don't have to. It's easier to transform. 1,500 meters is here. All right, let's take our equation. V equals d over t. 9th grade, 10th grade. So in 9th grade, you can feel free to replace the things that you have here and find the answer by replacing the numbers first. It's a waste of time, but it's intuitive. So V would be 10. D is 1,005. And T remains T. And what do we do now? Right? So again, we've done some examples. I don't want to divide by T because I don't want my answer to be like this. Right? That's not what I want my answer to be. I want T equals something. So I don't want to divide by T. This makes no sense. So let's get rid of divide by T by multiplying by T. We're going to multiply both sides by T. We're going to get 10T or 10 times t. You can do this if you want. 1005 divided by t times t. So of course, this cancels out with this. You get 10t equals 1500. Now what? Again, I want t equals something. I don't want 10 times t. So what do I do? What's the opposite of timed by 10? Divide by 10. So on both sides, we're going to divide 10. Divide by 10, divide by 10. And it makes sense because I don't want 10 times the answer. Times 10, divide by 10 cancels out. And on this side, a 0 crosses out another 0. So t equals 150. And you can see how 150 is 1/10 of 1005. We had 10t worth 1500. Now 1t is worth 150. And because our units were good, meters and seconds and only, we know the answer is in seconds. So this is the math that you've done in 9th grade. Honestly, it takes more time than what we're going to do with 10th grades. So let's go take a look at what 10th graders would do. Because this is Science 10, we would actually want you to do this. So our formula was this. We had everything but t. And we want to end up with a formula where t is equal to something. Here, t is equal to something. So t is called the focus. Now you might remember focus from the last lesson. So we'd like to change our formula, reorganize it so that t becomes the focus. So what do we do? Just like this example, we did not like that it was divided by t, so we multiply it by t. Well, guess what? We want t also. It's stuck under and it's no good. So we're going to multiply both sides by t. So we'll get v times t. You can put some brackets, but no brackets also is it times equals v over t times t. Right? Multiplied by both sides by t. d times t divided by t cancels out. The t's cancel out because you're timing by t and you're dividing by t. So what do you end up with? gt equals d. Hold up. That's a new formula. This is the formula for the distance. How interesting. We'll come right back to that. But again, my focus is t, so I'm trying to get that t alone. So t right now is multiplied by v. We don't want that. So what's the opposite of multiply by v? Just like we did here, v in this case is 10, so we divide it by 10. V in this case is v, so we're going to divide by v. So on both sides, we're going to divide by v. So will get, if I may go a little faster, divide by V, divide by V. This cancels out, and you're left with T equals, what does this say on top here? D divided by V. That's another formula. So that's what we wanted, what we would want people to do in 10th grade, is to transform your formula first, get the focus, then replace. Because we have D and V. So you just put those numbers in and you get the answer. Right? Because it was, what was it again? 1,500 meters divided by 10 meters per second. You would get 150. Then the meters and the meters cancel out. But you're left with divided by 1/second. So what do you do with a number like this? What are you allowed to do, right? You have this divided by this. This is the same. And you've learned what to do here in math. You can inverse, you can time by the inverse. In other words, seconds is on top. So this is the same as 150 seconds. Your seconds. When you divide by 1/second, it's actually, the second actually goes on top. Okay. So yeah, so you can see how it's a little cleaner in terms of work. We're going to use these equations now and put it in our repertory of equations. So we have V equals G over T. We've also found D equals TV. And the last one, T is equal to D over V. All right. In all of these, focus is different. This is the formula for velocity, or I say speed. I think it's going to be cool if I say velocity. This is the formula for distance. And this is the formula for time. So if you have a movement of constant velocity, you can find the velocity, the distance, and the time if you have at least two others. So that's why I wrote these on top of your document here, same way. Some teachers will show you finally the triangle. This triangle always works with a formula that's always on the same level. This formula is that everything's on the same level. There's no divisions. You can use your triangle like this with any simple formula like this if you're not yet accustomed with moving them around. So this is like a 9th grade stuff, a 9th grade helper. So you write D is your first letter, E in this corner, and V in this corner. Then you separate them like so. And basically what this what we can do with this is it's going to work with all of them. Basically, if you want V, let's say you have this triangle, and you're like, I'd like to have V because I have D and T. Say you have distance, 4 meters, time, 3 seconds, and you want to know what formula to use to find V. So V equals what again? You can use the triangle. And you can say, well, V equals D over T. See it? If you want V, you would say V. You can hide V like this. You hide it. You're left with D over T. On this one, you want D. So say you add D equals 2 seconds, V equals 20, 30, whatever. And then you're like, okay, I need the distance. I don't know what the distance is. How do I find? And the teacher is not nice. He didn't give us the formulas. So you get your little triangle out. Maybe he give you the triangle instead. What a pain. You have to figure it out. Okay, you hide D like this. You hide it. And you're left with T. And you're left with T times V. See that? So, you would write that in your formula. You would write D is equal to T times V. And the V over here would be equal to D times T over T, sorry. D over T. For the last one, we have T. We're looking for time. You have your triangle handy. You're looking for time, so that means time is distance over velocity. And you would simply write that here. Time equals distance over velocity. And you can do the problem like that. Okay, so the little triangle can be useful. So I'll put it here. Personally, I don't want to use it. I just want to know like one formula and then move the letters around. Okay, but one thing at a time. Okay, so I hope this is going to be enough. You have a few problems to do. Should be good for this week. And there's not a lot to kind of keep it simple. Good luck. We're almost done.